Welcome back to NetAdmin Lab. Today we're taking our infrastructure to the next level. After preparing our Proxmox host in the last video, it's time to deploy our first production node. We aren't just doing a basic Ubuntu server install. We're going to leverage the latest features of Proxmox 9.1, optimize our virtual hardware for maximum I/O performance on ZFS, and set up a bulletproof automated backup system on our 6 terabyte pool. Whether you're migrating from VMware or building a professional home lab, this is the configuration you need. Navigate to Local to ISO Images to download from URL. Reliability starts at the source. Click Download from URL. In a professional production pipeline, an unverified ISO is a security breach waiting to happen. Paste the Ubuntu LTS link, but focus on the hash field. We are using SHA-256 to verify the cryptographic signature. This ensures the binary hasn't suffered from bit rot during transit or malicious tampering. Proxmox 9.1 integrates this check directly into the storage layer. Always query and verify before the first boot. Click Create VM and follow the tabs. General and OS. Assign VMID 101. Use a structured ID scheme for easier firewall rules later. Select the verified ISO and set the guest OS to Linux 6.x to ensure the kernel expects modern para-virtualization. System, the core. Change the machine type to Q35. This is crucial. Q35 provides a modern PCIe bus topology and better support for interrupt remapping compared to the legacy i440FX. Switch BIOS to OVMF, UEFI, for faster initialization and modern EFI partition support. Most importantly, check QEMU guest agent. This is our telemetry bridge. Without it, your hypervisor is blind to the internal state of the guest. Disks, I/O orchestration. Set the bus/device to VirtIO SCSI. In the controller drop-down, select VirtIO SCSI Single. This creates a dedicated SCSI controller for the disk, allowing for independent queue depths and reduced lock contention. Enable iothread to offload I/O processing from the main vCPU. Check discard and SSD emulation. Since we are backed by ZFS, This ensures trim commands pass through, preventing write amplification and maintaining block-level performance over time. CPU instruction pass-through. Set the type to host. We want to bypass CPU emulation. By passing the host's instruction set directly, the guest gains native access to AESNI and AVX instructions, which is vital for SSL handshakes and high-speed encryption. Memory, predictable performance. We are assigning 4 GB of RAM, but the key here is disabling memory ballooning. In an architected environment, you want your guest memory to be pinned and immediately available. Dynamic allocation introduces latency spikes when the host reclaims memory under pressure. For server workloads, predictable physical allocation is far superior to aggressive over-provisioning. Network, throughput, and paravirtualization. For the network interface, we strictly use the VirtIO paravirtualized model. This provides the lowest overhead and highest throughput by bypassing legacy hardware emulation. We bridge this to VMBR0. For high-traffic environments, consider enabling multi-queue. This allows the network stack to distribute interrupts across multiple vCPUs, preventing a single-core bottleneck during heavy network I/O. The VM boots and the Ubuntu installer language screen appears. We initiate the boot sequence into the Ubuntu Ubiquity installer. After selecting our language and keyboard layout, we arrive at the first critical decision, the installation type. We strictly select Ubuntu Server, minimized. As an architect, your goal is to minimize the OS footprint. Fewer pre-installed packages mean a smaller attack surface, faster patching cycles, and reduced memory overhead. We are building a lean execution environment, not a bloated workstation. Now, we define the network identity. Move the cursor to the primary interface, likely ENP6S18, and select Edit IPv4. We bypass DHCP entirely and switch to manual configuration. Subnet. Enter the network in CIDR notation, 192.168.10.0/24. This defines our usable IP range and mask in one string. Address, we assign 192.168.10.252. This static mapping is essential for persistent service discovery and firewall rules. Gateway, set this to your upstream router. In our case, 192.168.10.254. Name servers. We use a 8.8.8.8. This manual handshake ensures that our server remains reachable at a deterministic address regardless of DHCP lease expirations. For the storage layout, we select Use an entire disk and ensure Set up this disk as an LVM group is checked. LVM, or Logical Volume Management, is non-negotiable in a professional lab. It allows us to resize partitions dynamically in the future without unmounting disks or losing data. We review the summary, confirm the destructive action, and move to the profile setup. This is the most important checkbox in the installer. Install Open SSH Server. Check it. We are building a headless server, and SSH is our primary management gateway. Without this, you're locked into the Proxmox console. We'll skip the additional featured snaps to maintain our minimized philosophy. The installation begins, and once the logs show install complete, we reboot into our new hardened environment. After the first reboot, we must finalize the hypervisor to guest link. Run sudo apt update and sudo apt install -guest agent-y, followed by sudo systemctl enable --now -guest agent. Observe the summary tab in Proxmox. The IP address and hardware stats populate instantly. Beyond telemetry, this agent is what allows Proxmox to issue an FS freeze command, ensuring our ZFS snapshots are file system consistent, not just crash consistent. To conclude this step, we verify our remote access by establishing an SSH connection from our workstation, confirming that the network stack and the Open SSH daemon are operating as expected. Navigate to Data Center, Storage, Add Directory. Now, we address the 6 terabyte ZFS pool. Proxmox requires a file-level interface for VM archives, so we register the pool as a directory storage type. Map the ID as backups_6TB and set the path to your mount point. Crucially, under Content, select VZ dump backup file. This bridge allows us to store compressed snapshots directly on our redundant ZFS-backed disks. Navigate to Data Center, Backup, Add. Next, we define the automation logic. Create a backup job scheduled for a low-traffic window, such as 3 a.m. Use snapshot mode to leverage our guest agent for a live, consistent capture. In the Retention tab, we implement a Keep Last 5 policy, a rolling window of safety that prevents storage exhaustion while maintaining a reliable recovery path. Click Backup Now and show the log Task OK. We trigger a manual test to verify the I/O path. Once the log displays Task OK, the orchestration is complete. Our Ubuntu node is now resilient, immutable, and production ready. If this deep dive added value to your lab architecture, please subscribe to the channel. If you'd like to support the ongoing development of NetAdmin Lab, consider checking out the Buy Me a Coffee link in the description. Your support keeps these technical sessions running. This is NetAdmin Lab. Stay technical. See you in the next one.